Good afternoon, everyone. I'm Jade Marcum. I'll be leading all the introductions today. It is our pleasure to welcome you to the 10th Annual GRADx Symposium. This event is organized by the Society of Duke Fellows with support from the Graduate School as part of Graduate Student Appreciation Week. Part of the Society of Duke Fellows' mission is to foster discourse across the disciplines by encouraging students to think broadly about their research and hone their ability to convey its importance to a wider audience. Our speakers today have been tasked with putting this mission into action at GRADx, and we are pleased to have individuals from across the graduate and professional schools here to share the driving questions behind their research. We hope these talks will spark great discussions, and the speakers welcome questions after their talks, as well as during the reception that will follow the event. Before we begin, we would like to thank these individuals in the graduate school whose continued support makes GRADx possible each year. We thank you, Dr. Bostrom and Dr. Crumbley. Dr. Bostrom advises the Society of Duke Fellows year-round and was instrumental in planning this year's event, and along with Dr. Crumbley, helped our speakers prepare their talks. We would also like to thank Dean Haynes for her sponsorship and support of the GRADx event. So with that, we would like to welcome our first speaker, and I apologize in advance if I butcher anyone's names. First, we have James Budinich, a fifth year studying music, who will be discussing Sonifying CRISPR, how to compose new music inspired by CRISPR genetic editing.
Thank you. The choreography of CRISPR is a new work that I composed for my collaborator, Gabrielle Lamb. She's the artistic director of Pigeon Wing Dance, and our piece will premiere this fall at the MIT Museum for their opening installation, all inspired by biological art. It will be installed as a film and will be accompanied by a live performance. Today I wanted to share with you 3 ways that I borrowed from CRISPR in my composition for this dance piece. First, what is CRISPR? It's clustered, regularly interspaced, short palindromic repeats. It's a long acronym that we don't really need to worry about right now, and it's basically a genetic editing process that cuts into DNA and inserts new information that can cure genetic diseases such as sickle cell anemia. It can fight cancer, and it can even create human organs in pigs for transplants. In our research about CRISPR, we came across a story where scientists managed to change the pattern on a butterfly's wings, the Vanessa cardui, using CRISPR. We were very struck by this, so we decided to use the butterfly and its DNA as source material for our composition. Using DNA as a compositional tool was a challenge at first, but I used the 4 bases of DNA, A, C, T, and G, as my source material. All of our chromosomes consist of thousands of these bases paired together. So I took this first melodic line. This is from the butterfly's first chromosome, and I made it into a melody. I assigned pitches to each of the letters. At the beginning, A is A, C is the pitch C, G is the pitch G, and I assigned the pitch B to T. And then it progresses from there, develops, changes. But I didn't want to just have a single melodic line. I wanted to create something a bit more complex that could weave together different ideas. So first I added in high notes, a register of higher pitched notes that could complement the first line. You'll see that the lower line, the high notes, correspond exactly to the main melodic line that's happening at the same time. It's the same letters, just a bit more spaced out. I also made it so that they correspond exactly to the same letter. A's coincide with A's, C's with C's, T's with T's, and G's with G's. So we can listen to this first example. You'll hear the melodic line, and you'll hear higher pitched notes that break into the texture. I wanted to build it out a bit more, so I did the same with bass notes. It's a bit more spaced out this time. You can see the distance between A, C, T, and G has grown, but they're still coinciding together. So now you'll hear the main melodic line, high notes are continuing, and a new lower layer. Now let's return to this image and the idea of cutting. CRISPR uses proteins to cut into DNA and add in new information. So I took from that and I literally cut out pieces of DNA from the previous examples that you've heard, and I created a new pattern, weaving them together in a new way, using new instruments to create a new musical texture. Again, everything you're hearing comes from the butterfly's DNA. I'm still using that as the source material. And finally, let's look at the PR of CRISPR, palindromic repeats. There are palindromes in DNA that CRISPR finds and uses those as guideposts for where to cut in. So I begin the piece with a series of 4 chords, and I end the piece with the same series in reverse. So we'll listen to a bit of each one, and you'll hear it begin with the synth here. Series of 4 chords that repeat, slowly growing, and the piece concludes with the same 4 chords in reverse, now in the guitar. Thank you.
I can't answer. Next, we have Maggie Swift, who is a 3rd year in environmental science and will be discussing how elephants interact with a seasonally fluxing landscape and what might happen when the waterholes that weave this tapestry disappear.
So I know I promised you all a talk about elephants, but first I'm going to start by talking about satellites. So bear with me, the elephants are coming soon, but my work relies on satellites to try and map tiny waterholes on an African savanna and figure out how elephants move relating to these waterholes. Welcome to the Kavango-Zambezi Transfrontier Conservation Area, or KAZA for short. KAZA sits as a confluence of 5 different southern African countries and covers over 200,000 square miles of savanna habitat. This is a map of the surface water that covers the KAZA region. Scientists around the world use maps like this one, created from satellite products, to study permanent water sources like rivers and lakes. However, these maps can't catch seasonal changes, and many of these features are too small for a global water product to catch. For example, imagine you're an elephant living in this tiny red box. According to this map, you have no water to drink. If you wanted to drink your water for the day, you'd have to travel hundreds of kilometers to the nearest river. And being a very large, over 12,000 pounds animal, you have to eat a lot during the day. So this kind of commute just doesn't work. This scenario that I'm painting for you isn't realistic. we know that there are thousands of tiny water holes peppered throughout this region that fill up during the wet season and dry up during the dry season. The animals know they're there too. Animals during the dry season will hang out near rivers where there's a lot of green vegetation, even in the dry season. But during the wet season, when the vegetation flushes and all these water holes fill up, the animals will move out using these water holes as stepping stones into the interior of the savanna. So if the animals know about these water holes, and we are scientists and we're studying these animals, we need a way to look at these water holes from a landscape scale. With a team of scientists from Duke and the World Wildlife Fund, we've managed to accomplish just that. There are three obstacles standing in the way of our research. First is the size of these water holes, second is cloud cover, and third is just the question of what is water from a satellite's point of view. For the first one, this is pretty easy. We use open source data from the European Space Agency satellite Sentinel-2, a pair of satellites that can see up to 10 meters square, which is just perfect for the size of these water holes we're looking at. Second, as you can also see from this image, clouds are a huge problem for remote sensing. They get in the way of trying to see what's on the ground. But by taking multiple images over several weeks from the same area and stacking them on top of each other, and then cutting and pasting around the clouds, we're able to deal with a lot of those issues. Finally, to deal with our water problem, we turn to infrared light. Through a trick of nature, infrared light, water absorbs much more infrared energy than the vegetation or the soil that might be surrounding these water holes. Use infrared indices and create a value for each pixel, and then compare that value of their infrared light to a threshold and say if it's above this threshold, it's water, if it's below, it's not water. So in sum, we took Sentinel-2 imagery, we removed most of the clouds, kind of hard to get rid of all of them, and we used infrared light to find all the water holes. Here, I'll let you watch them fill up and dry out as I give this talk. So in total, we found over 2 million water holes for this region. That is a lot of water that's being left out of ecological models. So my next step for my third chapter of my dissertation is going to be to take these maps of seasonal water that we've created and combine them with collared elephant data from Namibia to ask questions about how the flux of this water in the landscape and vegetation on the landscape can drive elephant movement. As vegetation greens up much faster than water holes can fill up, I'm interested in finding out if elephants are following the change of vegetation or if they have to wait for the water holes to fill up first. So now that we've taken a trip all the way to southern Africa, you might be wondering why we care. For starters, human-induced climate change has already had drastic impacts on the climate. You might not think that 1 degree Celsius is a lot, but at 2.5 degrees Celsius of warming, the Okavango River, which is the lifeblood of this ecosystem, is predicted to decrease in stream flow by 18%. Animals and plants and humans in this region will have to deal with 23 more drought days and 10% less rainfall per year. When a fraction of these tiny water holes that I've been telling you about becomes seasonally unreliable because of this drying, what might happen to these elephants and other animals that are dealing with or using these water holes to access vegetation in the interior of this landscape? It's critical to understand how animals are using this tapestry of water now so that when it starts to unravel in the future, we can anticipate and address where and how these creatures will be harder. Thank you to everyone who's worked with me on this project, and I'll take any questions. Yeah, so the question was about the infrared data, whether it's reliable and what was the threshold. It's a combination of a lot of different bands of infrared data, so I don't actually have the numbers for you, but it's a bunch of different colors of infrared, and you would a color. And we used hand-drawn maps of these water holes for certain regions to validate our data set. Accurate, which is pretty good for this kind of analysis.
Thank you, Maggie. Next, we have Travis Knoll, a sixth year in the history department, who will be discussing how did a country as racially unequal as Brazil come to unanimously affirm race-based university quotas as constitutional.
Here to talk about action in Brazil, the fifth largest country in the world, with its sixth largest population and 12th largest economy. In 2012, the Brazilian Supreme Court unanimously upheld race-based quotas in university admissions, paving the way for national legislation, mandated the practice in universities and federal employment. Policies had dramatic results, increasing black representation in Brazil, in Brazilian universities, under 2% in the early 1990s to over 50%. These results are important because over half of Brazil identifies. But even though it's important, it's no less surprising, because Brazil was the last country to abolish slavery, destination for over 40% of enslaved Africans in the Atlantic. I sought to understand how a country with a slaveholding legacy that still results in vast political and social impacts in Brazilian society delivered a unanimous verdict. The story starts with the first generation of black. After Brazil's 21-year military dictatorship sought to enshrine black religious liberty, university and education representation, and even reparations. Brazil's constitution, later legislation, law. Many of these came from working class and lower class backgrounds, as was the case on the left with domestic worker turned Senator Benedita da Silva, union leader Paulo Paim. As literacy and high school completion rates increased in the 1990s, the second generation of black politicians and activists sought to make education the center for mass political movement. There is a series of grassroots educational movements which got scholarships for their participants at private and public universities. These courses sought to not only prepare students for university, but instill pride in black culture and emphasize the importance of black citizenship. They also conducted old-fashioned lobbying, as you can see, with education leaders meeting with then Brazilian Supreme Court President Gilmar Mendes. Scholarships in place, and starting in 2004, a tripling of university slots in Brazil. Third generation of activists sought to prove that quotas would not divide Brazil or polarize it along racial lines, nor were quota recipients applicants. Many of them became leading journalists, public sector employees, and even lawyers who went back to teach and represent these very grassroots education courts in congressional hearings. This was the case with construction workers. Alta Ferreira on the right. But social movement history alone is not enough to explain how such a radical transformation occurred. It boils down to Brazil's Catholic roots. As you can see, many education initiatives started in churches, and the Brazilian Supreme Court still has a cross. The saying that most encompasses this ethic is treat the equal equally, and the unequal unequally in the measure of their inequality. It means in a democratic context that equal citizens in freedom get equal resources in society. It also means you cannot treat those who are unequal in society if they were as advantaged as those not suffering years of oppression. Happened in the United States? Equality being a center? We don't know in a merit-based society. But Lyndon Johnson once said, we want equality, not just as a legal principle, but equality as a result. We are to recognize address racial inequality. We need to admit that we too. Thank you.
Next up, we have Meredith Schmehl, who is a fourth year in neurobiology, who is going to be answering the question, how does seeing help us hear?
Any given moment, and your brain is processing dozens of sounds. Take this busy city environment as an example. Just at this one single intersection, you might hear a bus coming to a stop at a stoplight, sound of a car honking as pedestrians cross. Those same pedestrians crossing by you and having a conversation, music from a nearby street performer, maybe even your own cell phone ringing in your pocket. This creates a really complex soundscape. And even in a relatively quiet environment, such as this room, you actually hear a lot more than just the sound of my voice. You might hear the sound of the projector, or the person next to you shifting in their seat, even the sound of your own breathing. So in this complex sea of sounds, how does the brain separate? All of these sounds enter your ears at the same time. This means your brain has to process information about all of these sounds at the same time. Your brain has to make decisions like, how many sounds are there? Where are those sounds located in the space around you? And which sounds are the most important ones to listen to or to act upon? Hopefully you can appreciate that this is a really complicated task for the brain to accomplish. And we don't entirely understand how it works. But what we do know is that at least part of how this happens has to do with what we see. So imagine that as you're walking down this city sidewalk, you encounter a friend who waves to you, gets your attention, and tries to strike up. In this complex soundscape, what might you do to help your brain process the sound of their voice? Well, one of the things that we might do, even unconsciously, is read the person's lips as they speak. Because now you have a visual cue that goes along with the sound of their voice and helps you listen better. This is what I study in the lab as a graduate student in neurobiology. I want to understand how this happens in the brain. How does visual information help us become better listeners? The way that I study this is by working with monkeys. You probably know, monkeys and humans are very genetically similar. This means that our brains are also very similar. So whatever we learn from monkeys is very likely to be applicable to human brains as well. This could have all kinds of implications, as in clinical settings, for people who have experienced sensory loss. The way that I study this is I've trained a monkey to play a game. The game is she sits in a dark, quiet room with a row of speakers and small lights placed in front of her. I can play sounds from these speakers and turn on these lights in different combinations. For example, I might present a sound over here and a sound over here at the same time. Maybe one of those sounds is paired with a light, mimicking that friend walking down the street as you read their lips. The game is the monkey has to locate everything that she sees and hears. As she does this, I can record from her brain. A typical monkey brain might have somewhere around 100 billion neurons, a lot, but each day I find just one of these neurons to record from while the monkey locates these. So I can record these neurons' responses to sounds, lights, and both put together to try to understand how the monkey is using visual information to help it to locate these. So maybe the next time you're walking down the street and you meet a friend, or you're at a crowded party and you have to use visual cues to help you listen, you might have a better idea of how neuroscientists are trying to do this works in the. The question is, what are the advantages and disadvantages of studying just one neuron at a time instead of other types of brain scans that might get you a larger picture of what the brain is doing? That's a great question. So in my case, we're really interested in one neuron at a time because individual neurons are known to have responses to these different stimuli that might change depending on what's in the room. And we really want to zero in on a particular part of the brain and understand what it's doing. And so studying one neuron at a time helps us do that. But there are definitely advantages to getting a broader scale view of what many parts of the brain are doing. It's just that you can't necessarily zero in on individual neurons in those cases, so you kind of have to choose, do you want many brain regions or just one? The question is, have I tried a more complicated task? Do you have an example of what type of task you're thinking about? So the example or the question is about using more natural images as opposed to just a light. I personally have not tried that, but other people have. So for example, there are responses in monkey brains to faces. If you show the monkey a person's face or a monkey's face or a natural scene, you get responses to those as well. So other people are studying that. The question is, what if we presented a sound and a light at two different locations? That's not something that I'm doing in my experiment, but previous members of our lab have done that, and they did some really interesting work looking at when do you think that two things come from a location as opposed to different locations. So yes, that's definitely something that we can study.
Thank you, Meredith. If anyone else has any more questions, feel free to ask during the reception later. Our next speaker is Cole Wicker. Cole is a second year in the Liberal Studies Department and will be presenting on how can history inform land conservation.
Wonderful. Thanks, y'all. Hello, everyone. My name is Cole Wicker. My pronouns are he, him, and his, and I'm here to ask the question, how can history inform land conservation? You might be wondering how I came up with this question, and To be honest, I've always loved the outdoors, but like many folks at the beginning of the pandemic, I found myself outside every day. Couldn't go inside, so I spent time on trails in the area, walking the same paths every day. And I realized as I walked the same route that I would pass these stones that didn't look quite naturally placed, right? Or these structures on trails that didn't quite make sense, or objects that looked like they just didn't belong there. And I realized that there's a story to be told in these spaces that we take as natural, or spaces that come to be very naturalized to us. And so I thought about doing a little bit of a case study. And in 2007, the North Carolina General Assembly approved the Deep River State Trail, running from its headwaters in Guilford County through its confluence with the Haw and Cape Fear rivers near Chatham County, North Carolina. The Deep River State Trail was designed with recreation and biological importance in mind. But as I dug into the story of the Deep River, I realized that much of its regional history and much of its past really tell a different story of why it should be preserved, why conservation in this area matters. So I thought it would be interesting to dive in a bit deeper, particularly in one section closer to my own home, my own upbringing, to ask the question of how history in this area really shaped the spaces that we came to use, we in the broader sense, we in the community, to get outside, to recreate, and to engage with these seemingly natural spaces. Now, many of the current parks around today that folks use to go paddling, to go fishing, to go picnicking on the weekend are designed with history in mind, even if we don't quite realize it. In the upper left-hand corner, we have the Camelback Bridge, added to the National Register of Historic Places in 1995. It is now a gateway park to this community. On any given weekend day, you'll see tubers out there where people will spend quite literally 8 or 9 hours on this river, putting in and taking out right at this location. The bottom right-hand screen, we see the abandoned Sandhills Company Powerhouse in Carbonton, North Carolina. It's about 13 miles upstream from that Camelback Bridge. This is an important location because it brought power to this Tri-County area in 1921 and really allowed these rural communities to flourish. Both of these parks were designed and designated with these two historic structures in mind. And so there's this pattern where we look at historic locations and then conserve those lands and then naturalize them to become these natural outdoor spaces that folks use, even if they don't quite understand or know what's beneath the surface. So I thought, why not look at this lower section of the Deep River and take an examination of what historic artifacts, historic locations, former communities existed in this space. So I combed through some historic documents, and I built this map. And all of a sudden, when you put that map together and look at those historic sites, look at how we remember the past, and public lands that are either now currently used as parks or on the docket to become parks, there's another story that's to be told. So we'll zoom into this little community of Cumnock. On the upper left-hand side of the screen, you can see one blue dot. That is the Camelback Bridge. It's, as I mentioned earlier, on the National Register of Historic Places, and it's a pretty well-known regional location. But just below it, you can see a hatched fill, and this is a really exciting advancement. And about 3 years ago, the North Carolina State Historic Site System acquired the land to the indoor iron furnace, a 19th century Confederate iron furnace that fueled efforts during the Civil War, and now have protected about 300 acres of land that are being dedicated as a park in the coming years. So there's this pattern that we see repeating of parks in the past being dedicated and being conserved for the purpose of historical conservation. We see it happening again in the future. And so I'm curious to know how else we can do that. What other spaces here can we do that? What other spaces can we use with that in mind? This might be the Farmville and Egypt coal mines, the only two historically profitable coal mines here in central North Carolina. But there's no sort of acknowledgement or public way to access these areas. So I wonder, how can we use those other aspects of the Camelback Bridge, of the indoor iron furnace, to take a step into the past, engage with these useful spaces, and actually use history as a mindset in how we can preserve lands for public use, public recreation, with any of that in mind. So I know that was fast, but I appreciate you all being here today. Are there any questions I can answer before I wrap up? Yeah, absolutely. So in this case of dedicating these lands, does it happen sporadically, in large chunks, or over time? And really, it goes down, I think, to a long span of time where people are invested in this. So the Camelback Bridge is a project that was near and dear to a community member's heart. She started an organization and built that, and really got the ball rolling there. The same with the indoor iron furnace. Some folks may know the Triangle Land Conservancy, which actually runs many parks in the Durham area. Two of their parks, which is the indoor iron furnace land originally, and McKeever's Landing, a historic mill, now used as a paddling launch, really started ground roots effort building over time. So it's exciting to see that 300 acres of land being conserved right now, because it's something that does take time to happen. I know I'm about out of time, so thank you all so much.
Our next speaker is Nidhila Masha, a third year in the School of Medicine, and they will be answering, in individuals with multiple sclerosis, does childhood exposure to secondhand smoke increase severity of multiple sclerosis? So,
now, let's take a trip in time and space to Holland, 1395. Now, the child up here with the halo is Saint Lidwina. She's best known for being the patron saint of figure skating, but most importantly for us, she's also the first recorded person with multiple sclerosis. Now, they didn't really know what multiple sclerosis was back in those days, so her diagnosis was made retrospectively based on some records in the church history. The symptoms she experienced were actually textbook for what we now know as MS today. She had vision loss that affected one eye. She had weakness that would later progress to difficulty walking and then paralysis. And she had pain. A lot of patients with MS. Which brings us to the question, what does MS look like from a patient perspective? So here's our patient, patient X, immediately before the MS began. Over the next couple of years, she'll experience flares of symptoms, including vision loss and the motor weakness depicted here. Patients do usually recover from their flares. They can have either full recoveries, as we see here, or partial recoveries. And sometimes patients also gradually accumulate disability, even in the absence of flares. And this is what makes treating MS so important. Inadequate treatment can increase the severity and the frequency of the flares, but it can also speed accumulation of disability. The problem is, the treatments we use for MS are not benign. In addition to side effects like pain and diarrhea, they also can cause severe infections by weakening the immune system. And this makes treating MS a balancing act. What you want is to decrease the risk of disability as much as possible without making the infection risk unacceptably high. And this is hard. It's hard to figure out what that magic number is because it's so different for every patient. Some patients have aggressive courses and need to be on aggressive treatments, as the disability risk for their MS is so high that it outweighs the infection risk of even our most immunosuppressive medication. But some patients have more indolent courses, and for them, the infection risk of our highly immunosuppressive meds outweighs the disability risk of their MS. So they do not need to be and should not be on the really aggressive medication. Identifying predictors of MS severity can help physicians identify the high-risk patients, ones who would benefit from more aggressive monitoring and more aggressive therapy, and help them start these individuals on the aggressive therapies earlier in their disease course. The purpose of our research is to determine whether childhood exposure to secondhand smoke is such a predictor. Now, why did we choose to study secondhand smoke? Well, there's been a good bit of research on the connection between firsthand active smoking and MS. Individuals who smoke are not only more likely to develop MS, if they do develop it, they're more likely to have aggressive courses. And there's just not been a lot of research done on secondhand smoke. The few studies that looked into it found that exposure to secondhand smoke, especially in early childhood, adolescence, it may increase your risk of developing MS, but does it increase your risk of developing severe MS? We don't really know, but that's what we hope to find out. In 2018, researchers at our lab sent out surveys to all the MS patients who were then receiving care at Duke, who found out, among other things, their smoking history and their exposure to secondhand smoke. It also included several questions about their level of functional ability. What activities could they still do? What activities could they not do? What activities could they do, but with a lot more difficulty? Around 175 patients actually did respond to our surveys, and we hope to use the responses to determine if and how disability correlates with exposure to secondhand smoke. In doing so, we hope to identify another predictor of aggressive MS in order to help physicians and patients tailor treatment decisions and navigate that tightrope between infection and functional ability. More questions? So the question is why we were interested in studying MS. So I work with the neuroimmunology department, and MS is one of the most common conditions we see, and it is also the one that has a high level of disability, and there's a need for more research done on it. So it's a focus really of our department as a whole, but also the specific lab I work with. So the question was the effects of secondhand smoking we're thinking we may see. Is that just secondhand smoking as an infant or as a child or adolescent? So that is a fantastic question, and that's something we also hope to tease out. From the data done on firsthand smoking in MS, it's not only exposure in infancy, childhood, and adolescence, it's also exposure as an adult. So exposure to smoke at any point in a lifetime, we think, may impact risk of developing MS. So again, that is a fantastic question. Our lab specifically has not looked into that, but there are plenty of studies looking at the effects of other toxins on and teasing out the core. I think that might be all my time, and I will let the next presenter go.
Thank you. We're actually going to take a very quick break, so we'll be back in about 3 minutes. Welcome back, everyone. We're going to go ahead and get started with our second round of speakers. Our next speaker is Jennifer Kades, a third year in the economics department, who will be discussing, as part of the story of the Great Resignation, a shift in the psychological cost of unemployment.
Thank you, everyone. So today I'd like to talk to you about psychological costs in the labor market. So the labor market, like any market, has two sides. We have our employers, or firms, and the workers. And in a healthy labor market, they battle each other for their own self-interests until they reach an equilibrium that's acceptable to both sides. But as we've seen over the past few decades, the labor market in the U.S. has felt more like this. There's been kind of an imbalance, and it's felt like employers and firms have kind of had the upper hand. We've seen benefits being stripped, we've seen working hours creeping upwards, and most of all, we've seen really stubborn wage stagnation, even at the same time that firms are recording record profits and record productivity. Now, as we've seen, COVID seems to have turned the tables somewhat and returned some power back into the hands of workers. After an initial spike in unemployment, we're now seeing unemployment below pre-COVID levels. We're seeing a record number of job openings, a record number of people quitting their jobs. Wages are finally rising, and unions might even be making a comeback. Now, most of the existing research in economics studying this power shift in the labor market has focused on two pretty concrete explanations. It's focused on shifts in the financial cost of unemployment due to government benefits induced by COVID, and it's focused on shifts in the physical cost of employment due to COVID risk. But other research in economics has shown that states with differing levels of generosity in their unemployment benefits haven't had very different labor market trajectories. And we know that these massive quits that we're seeing aren't limited to the populations that are most at risk from COVID. So it seems like these financial and physical shifts in the cost of employment aren't really telling the whole story. On the other hand, some of these social phenomena that we've been seeing, such as people posting their quit videos to social media or quit talks, do seem to indicate that there's more intangible forces at play. In other words, it does seem, at least anecdotally, like COVID has shifted the psychological cost of unemployment or social attitudes towards unemployment in a real way. Now, how did it do that? Without getting too into the weeds, I think there are a few possible explanations. For example, I think it's possible that this massive amount of layoffs at the beginning of COVID, which created this population of people who are unemployed due to absolutely no fault of their own, may have reduced the stigma of unemployment to other people. Now, taking a step back, economists have been borrowing from psychologists for a long time, and we do know that psychological costs shift markets in real ways in a lot of settings. For example, there's a large body of research on psychology in financial markets, and we know that emotional trading can create weird speculative bubbles and other distortions in asset markets. Similarly, in consumer goods markets, psychologists and economists have done a lot of work looking at how things like identity and social norms shape what we buy. But psychological forces in the labor market are more of a black box. We just don't know that much right now. We know some things, like that our identity and our self-worth are very much tied to employment and our career success. And we know that this depends on the social context. For example, there are studies showing that employment or unemployed individuals seem to be happier in areas where there's higher unemployment, even though this should, in theory, make it harder for them to get a job. But we don't really know, in a more holistic way, what drives these psychological costs of employment or unemployment and how they feed into labor market power. It's hopeful that studying this in the context of COVID should help us understand psychological costs in the labor market more broadly. Thank you. Any questions?
Are you interested in just studying the U.S. labor market or other, like maybe a comparative study?
Right, it could be comparative right now. I'm just focusing on the U.S. labor market just because that's kind of knowledge bases, but definitely be interesting to compare. Yes?
What are some tangible ways to define the psychological cost? Like, if you are to look at some markers, could you give some examples?
Yeah, totally. So the question is about measuring psychological costs, and that's obviously the difficult part, right? Right now, what I'm thinking about is there's a lot of new ways of using text analysis. So I'm thinking about looking at media and news sources to kind of measure how sentiment towards unemployment has. Okay, go ahead. So the question was about any other factors that contribute to being happier when unemployed. So we definitely know that, people prefer leisure to labor. That's kind of the underlying idea in the labor market. So certainly people, when they have more leisure time, should be happier, but we also know that people do seem to prefer being employed, all things equal, like we said, because of these identity and social norms costs. But yeah, more leisure time is a positive of being unemployed. I think that's all my time, but thank you.
Thank you, Jennifer. Our next speaker is Akash Singh. Akash is a third year in the Mechanical Engineering and Materials Sciences Department, and we'll be discussing how an engineered phase of a synthetic mineral could broaden up its application space.
Well, thank you so much for the introduction. Don't bother about the title, I also don't understand it. So to make things simpler, I'm going to take you all to a 200-year journey of a mineral in the next 5 minutes. And it all began in 1839 when a German scientist went to Ural Mountains in Russia for some leisure time, and he accidentally stumbled upon this mineral, which later was known as perovskite in the honor of a Russian mineralogist, Perovsky. This mineral contained 3 elements: calcium, titanium, and oxygen. Later, before the World War I, at a Yale University here in the United States, scientist H.L. Wells actually first synthesized a halide perovskite by replacing some of these elements. It was only later, after World War II, that the structure of these perovskites were determined, and it was found out that even when these elements are substituted, the structure remains the same. And at that point, perovskite was no more a mineral, but was known as a structure. And this happened at a very different place, somewhere in Denmark. After this, in 1978, D. Weber in Germany actually changed the entire game. He somewhat introduced an organic capability into this inorganic moiety of the crystal. So instead of having only inorganic material, he infused some organic part into it to make the material both organic and inorganic. Getting best from the both worlds of organics and inorganics, this perovskite caught attention of a scientist who was working at IBM 2 years before my happy birthday. And that was when a series of composition and different dimensionality of this compound was prepared, and their optoelectronics properties was studied for the first time. And that led to the creation of the first transistor and LED using such materials. 15 years down the lane on the eastern side of the globe, Miyasaka from Japan used these materials in solar cell with efficiency of around 3.8%. After that, perovskite became a global celebrity in the field of photovoltaic research, with efficiency reaching as high as 25.7%, which is comparable with the commercial silicon-based solar cells today in the market. What it means. So if you take the example, an anecdote told by Sam Stranks from University of Cambridge, if you imagine an Olympic-sized swimming pool, and if you put the perovskite ink, the precursors which we use to make perovskite solar cell, and if we barely fill half of this swimming pool and use that material to coat over different substrates to make solar cell, it can power all of California. So it is changing the game as we are trying to see it. Applications, and perovskite did not stop there. Not only they are used in solar cells, LEDs, lasers, transistors, but they are also used in photodetectors, X-ray detectors, gamma ray detectors, data storage, as well as in quantum computing today. So that brings to the point, this is a 200-year journey, but up till now I have only covered 184. What we did in our lab, out of mere serendipity, we changed the crystalline ordered phase of this material into a randomly arranged glassy phase. So we changed the phase of the material. How we did so? If you actually look at any material in a crystalline form, if you heat it beyond a certain point, it becomes a liquid. And if you cool it, it again converts back to its parent phase. But what happens if that liquid is cooled in such a super fast manner that the atoms that actually make up the structure do not get time to return back to their home position? that leads to the creation of glass. Glass is a metastable state of matter which is physically similar to solid but structurally very similar to liquid. And because of this, it leads to various configuration arrangements as opposed to a limited few that is available to the crystalline counterpart, and this leads to multiple functionalities. In my PhD, I used some inspiration from Walter White from the Breaking Bad to cook some of these perovskite crystals using some synthetic design principle and with different structures and to induce various glass-forming propensities in them. I study their properties and try to see where I can explore these properties to be used in the application space, the emerging application space of flexible and stable solar cells, emitters, phase change memory, energy-based storage materials, optical fibers for transatlantic and transpacific communication, optical memory, electronic memory, as well as in optical computers and brain-inspired neuromorphic computing. 16-year journey of this 2-century tale is yet to be completed, yet to be charted, and one can only imagine where these materials could be used in the future and what for. Thank you so much for your time, and that's my group. I can take questions. Sure.
What do you think is the most exciting application for this?
The most exciting application for this is solar cell, for sure. Right now, when I said the efficiency has reached at par with the conventional silicon cell, the problem with these materials is they are inherently unstable in the ambient environment. Glassy materials tend to have no grain boundaries, which are known to be the main cause for the oxygen and moisture to permeate into the bulk of the material that causes the degradation. So the glassy material has no grain boundaries, so perhaps they can stabilize these materials, but they can be marketed and commercialized. Perhaps in the next 16 years, we'll use those kind of solar cells instead of the bulky silicon-based cells.
Oh yeah, there you go. So I guess like in talking about the applications and the options, like what are like the cost benefits that you see in the different fields of application that you can have, for instance, in solar cells and maybe other?
Yeah. So if you see the levelized cost of these solar cells for the silicon, the conventional one, the prices have come down drastically. Right now, it is around 31 cents per watt. And with this new budding technology, which can be solution processed at nearly about less than 100 degrees Celsius, which is thermally effective, the prices are projected to go, right now it is at around 17 cents per watt, which is like around half of the conventional cell, but we imagine it to go as low as 7 cents. Yeah, so in NREL, National Renewable Energy Laboratory, there was a scientist, Matthew Beard. He found out accidentally while measuring the photoluminescence of these materials that you can actually control the spin states of these materials by introducing chirality into the system. And if you can control the spin, you have a quantum computer. Thank you.
Next up, we have Sam Hall. Sam is a 5th year in the Nicholas School of the Environment, and the title of their presentation is Forever Chemicals. How can we better understand the human exposure and health effects of these toxic PFAS chemicals in North Carolina?
I'm Sam Hall. Today I'll be talking to you about doctoral research on forever chemicals, also known as PFAS, specifically in North Carolina. So first, what are PFAS? PFAS are per and polyfluoroalkyl substances. They're this huge class of chemicals defined by these carbon-fluorine bonds, or fluoroalkyl groups. I'm here with the green and the black bonds. And this carbon-fluorine bond is really strong. It's very stable, and it leads to these chemicals being very persistent. So persistent, in fact, that they're called forever chemicals by many people, and they don't break down in the environment, or at least many of them don't. EPA estimates that over 12,000 different PFAS chemicals exist
in many different kinds of consumer products. Because of their stability, they're really useful chemicals. So if you have a product that is non-stick or waterproof or stain-proof, it's likely that there's a PFAS chemical in it. So your waterproof boots, your rain jacket, your non-stick cookware, your waterproof cosmetics, even your takeout food packaging likely has PFAS chemicals. So why do we care? Why do we care that PFAS chemicals are in so many different products? Well, one reason we care is that we can detect these PFAS chemicals in all of us. Nearly every person in the United States has. Even across the world, we can detect PFAS. And in addition to our blood, we can also detect milk and in newborn babies, ensuring that the next generation is also being exposed to these forever. And then if it wasn't bad enough that we're detecting it in anybody, they've also been linked to harmful health. Some particular PFAS have been associated with certain kinds of cancer, with higher cholesterol, and with reproductive effects, or decreases in infant birth weight. And then unfortunately, the 12,000 PFAS that I mentioned, many of them haven't been well studied. We don't have a lot of information about them. We don't know, for many of them, whether they're toxic or harmful to us. In our backyard of North Carolina specifically, PFAS are also a big problem. Our lab and other groups have detected PFAS in lots of surface water across North Carolina. And for many communities, the surface water is a source of their drinking water. Fortunately, because standard drinking water treatment doesn't remove PFAS, what ends up being in the rivers ends up going to our drinking water and then into us. In the Cape Fear River watershed alone, about 1.5 million North Carolinians. So then what can we do? My doctoral research really focuses on researching PFAS exposure. We're getting better information on figuring out what this problem is and how we can solve it. So in my lab, we can use analytical chemistry techniques to detect where PFAS are in the environment. Look at what kinds of PFAS are in drinking water and at what amounts. Look at what PFAS are in the dust in our indoor homes that we're breathing and ingesting. Also look at the levels of PFAS in our body, what PFAS are bioaccumulating in our blood or even in tissues like the placenta. And then once we have a better understanding of the kinds of PFAS we're exposed to, we can take that a little bit further and look at associations with health. We can ask questions like, is higher PFAS exposure associated with higher cholesterol in certain North Carolina communities? Or questions like, is more PFAS in the placenta associated with having a lower birth weight baby? Those are some of the questions we can answer and ask and learn more information so we can better prioritize which of the 12,000 PFAS we should be seeing more, which ones we should use, and which ones we should regulate, and have a better understanding of making a better, more informed decisions and safe communities. I will take any questions.
With PFAS being in all of us, how can you determine that certain PFAS will cause certain diseases, health issues, health-related issues, and also I mean that we all have different PFAS or all have the same PFAS?
Both. So there definitely are some common ones that many people have. So two specific ones, PFOA and PFAS, are in a lot of different people. Some other ones, like people in Wilmington, North Carolina, are exposed to some of the newer replacement PFAS. So they're exposed to certain specific ones from facility. As far as how we know that these are associated with different health effects, one, we can do animal studies so we can establish causation if you expose an animal to something, and you can see what effects happen later. Another really good source of this health information this epidemiological study done in West Virginia. There's actually a movie, Dark Waters, with Mark Ruffalo about this issue, where this community was really exposed to high levels of this one PFAS called PFOA, and they enrolled about 60,000 different people into this epidemiological study and followed up with them and found a lot of the different. Again, that's only for one PFAS. We don't have information on thousands of others that are in use in products or in the environment. There is a lot more we need to do.
Okay, so a question on Zoom is, does fluoridated, I think that's right, fluoridated water stabilize PFAS or chemically react from them?
Ooh, that's a great question. I believe that they're unrelated. So the fact that there's fluorinated water for dental cavities and all of that, don't think that's related to PFAS at all. Certainly there's a bunch of different fluorinated chemicals in our water, like pharmaceuticals and pesticides, fluorines in them. But I don't believe adding fluoride, that's like ionic form, that's not an alkyl, fluoral alkyl form. Our next speaker is S. Monroe, who is a second year in the neurobiology department and will be answering the question, is the vagus nerve an immune signaling pathway during respiratory infections?
So, as I was kindly introduced, I'm a neuroscientist. We think a lot about the brain, but funnily enough, we have an entire body attached to our brain. So a lot of other biologists have been excited to see attention to the brain axis, where people see how our gut and our brains interact with each other. We have another organ similar to the gut, which is those large mucosal surfaces that interact with our environment. But unlike the gut, where we have a lot of control over what we eat and what goes into our bodies, we have very little control over what goes into our lungs. Experiencing the air in our workplaces, in our homes, and in our cities. So people in urban centers like Cairo, shown here, experience much higher levels of pollution. Cairo has very high pollution because of emissions, but also because of its geography. And in society, we have very little control over these large factors. But it's not just where you live, it's also day-to-day changes. This is the same city taken 10 days apart, and you can see there's a huge difference in Carolina. We have, all of this pollen falling right now. We have all of these day-to-day changes and apartments versus houses versus our workplace. So our body needs to be able to rapidly adapt to these. We also know that children have less control over their environment. They're even more sensitive to these changes. Especially in urban centers, you see higher incidence of asthma and allergens. And we also know that these are linked to our brain health. Asthma are much more likely to experience anxiety as well, more to an extent, more so than is just explained by vital perception and treatment. So all of that paints a picture where we have no control over our air or little control. We also know that it is very impactful to our. What is our lung actually? Biology behind that. So the kind of canonical model is that if you have some challenge to your lung, it causes inflammation. That inflammation can reach your brain. Let's say you have inflammation in your body, whether that's air pollution, a bacterial infection, that causes the upregulation of inflammatory molecules that circulate around your body, and they can actually reach your brain. And the brain itself becomes inflamed. What I want to know is we're constantly changing our environments, but these cytokines, these inflammatory molecules, can take days to change. Is there a faster way that the brain can tell what's going on in the world around? That's where the vagus nerve comes in. A major nerve that innervates many of our organs. It regulates your heart rate, your digestion, your breathing, and it acts as a highway of information. Interestingly, the vagus nerve directly innervates very special sensory. cells are situated at the major airways, branch points of the airways in your lungs. So they're kind of the first cells that are hit with any kind of particulate matter, any viruses, any allergens that are coming from. So in order to study this, my lab is going to use flu infection as a model. We're using flu infection because one thing that's important about science is being able to replicate it in different labs and compare. Our environments, our climates are very different. We can't necessarily control all of the air quality, but we can control exposure of. So, the hypothesis that I'm looking at is that if you have a flu infection, and in this case I'm working in mice, you have some direct communication with cells through the vagus nerve straight to your brain. So I'm really looking at seeing whether this lung vagal signaling can act as a rapid detection method. So first, to address this, I'm undergoing experiments where I've given mice the flu. I then look at their brain tissue. I actually slice it very thinly, and then I image each of these slices. I've stained the immune cells in purple as well as active neurons in red, and I can look across the brain to see where are these changes occurring. The brain is very, very big, and I'm making very, very many slices. With this very large data set, with the help of Francesco from the lab of Trello Reglu, I'm implementing a machine learning algorithm. The idea here is that you take my very large image set, I'm taking subsets of the images and manually scoring what I think is important. Feed this into the algorithm, which then uses that as a guidebook to assess the entire data set. If it does a good job, that's great. If it doesn't do a good job, I can create additional training images. With this method, I can rapidly look at every region in the brain and get a stronger sense of what's going on in the neuroimmune landscape. So that's kind of the establishing work of my project. Ask, will the vagus nerve influence this immune response? And we have several neuroscience tools that we plan to use, including which I won't go into here, but I'm happy to talk about. Thank you. Oh, I'm sorry. One more slide. As I talked about for air pollution, but it's also a pandemic as we are experiencing of novel viruses, which are, we all know, probably here. My lab and also the other people that I work with.
So, is there, like, because right now I understand you're using histology images, right? Is there another, like, option for imaging that you could use to train the machine learning algorithm?
So, if I understand your question, you're asking, I'm using solitary images now, but is yeah, I think here my images are solitary and that, and then addressed separately. It would be really interesting to look at kind of, I'm looking at each plane. These planes are next to each other, and there's also lateral information through them. The one imaging technique is keeps the tissue whole and through it all and make a 3D data. So I would love to implement this algorithm.
Our next speaker is Kiri Ju, a first-year economics student, who will be discussing the question, how does corruption affect innovation?
Hey everyone, my name is Kiri Ju. I'm a first-year economics. So my projects relate to, I'll start from the first slide, which is my title of my research. Two components, corruption and Schumpeterian world. What is Schumpeterian world exactly? Schumpeterian model, I mean, synonym in my research use Schumpeterian world. It's actually first proposed by Joseph Schumpeter, an Austrian economist, 1942, saying that in the long run, technology innovates, and each company tries in a perfect competitive market, they handle the competition by innovating their own products, and new technology always replace old technology. This becomes the basic model where my research originated from. In the basic model, each consumer bear a certain level of utility functions, and they also to maximize it by finding and matching their ideal products. And the companies also bear a profit function, and given a certain that they also want to maximize their own profit, and at the same time they also conduct in. This is a basic setup in my model, but for the corruption in the usual area research was not really covered by some institutional economists. For example, Darren Acemoglu, 2012, proposed that the corruption is usually referred as institutional cost for he call that less inclusive institution versus open access institution. So in that case, he concludes that in some bad institution, where he called limited access institution, there is not common to do innovation. However, my research kind of rejects his points from that. In my research, I incorporate corruption part and Schumpeterian setup, therefore forming the new model. That's a slide. So on one side, we have corruption, and on the other side, we have innovation. For the corruption side, there are two types of corruption in the model: grand corruption versus petty corruption. The grand corruption setup, there's the central government. It has really serious corruption, therefore impairs the fundamental function of the government. But in the petty corruption setup, holding a small number of companies of corruption. Therefore, the majority of the function of government still remain intact. In my research, that even though the incumbent officials have corrupt behavior and can efficiently regulate the market, but in that case, but it's only for some certain department. But the incumbent companies, also facing the competition from other markets. Therefore, that this kind of pressure still driving the company to conduct it. And I think that's basically my research about. Sorry, I feel a little bit nervous. It's my first time doing this kind of speech. Sorry about it. Yes, that's all I have for today. Thank you, everyone.
What inspired you to look at corruption and innovation?
I'm a first-year student. I guess in my undergrad, I'm kind of interested in how historical perspective of institutional economics. But I have not think about the innovation part of economics. But it is until my study in Duke that inspired me to say, one of my professors talking about how how economists model innovation in their research. But I think maybe I could combine those two factors together and write my own model. Therefore, to successfully modeling how does the innovation and corruption interact with each other.
What do you think where U.S. stands in this off-trade balance?
Can you repeat that?
Where does the U.S., this country stands in this balance of off-trade between corruption and innovation?
So you say that there's a research about that?
No, so I just wanted to know where do you think U.S. stands with side? Like if it is more innovative or corruption, are you also trying to measure this based on different countries as well?
Oh no. So my model is not an empirical one. So it's completely a theoretical one, so it does not based on specific country. That's also the characteristic of most of the Schumpeterian model. So yeah, in general, like it's not a country-based model, like, but it just stands for all of the countries. I would say doing this kind of empirical work is kind of challenging because it's very hard to find data on corruption. Therefore, it's just hard to measure that.
Thank you so much.
Thank you. Our final student speaker today is August Franchette, a fourth year in the Mechanical Engineering and Material Sciences Department, and they will be discussing what could the future of household water use look like in the United States.
Hi, everyone. So before we jump into answering this question, I wanted to give you all a little bit of background about this topic and introduce why it's important for us to ask these questions. What's the future of household water? So I work at the Center for Jade, which is short for Water, Sanitation, Hygiene, and Infectious Disease. And we research and develop technologies that support the United Nations' 6th Sustainable Development Goal, clean water for all. So the goal is to provide every person with adequate access to safely managed water and sanitation services by 2030. To put this goal into perspective, in 2020, only 75% of the global population had access to safely managed drinking water, roughly 2 billion people to rely on a drinking water source that had fecal matter present in it. Now, here in the United States, we're quite removed from this bleak reality. We drink from relatively safe sources of fresh water, and when we flush our waste down the toilet, we don't have to think about what happens to it, who deals with it, where it goes, etc. I wanted to talk to you about an issue that's starting to hit a little bit closer to home: water scarcity. We have drought exacerbated by climate change and in regions you wouldn't necessarily expect. We have population growth in water-stressed regions. Here we can see in some areas with our highest growth and most limited resources, we have our highest rates of water usage per person per day. And of course, we have pollution from industry, agriculture, and you guessed it, sewage. Here's an example of coastline contamination in Hawaii, where a keep out of water sign indicates the presence of fecal matter, and a bright green fluorescent dye shows its concentration at the shoreline. Despite all of these stressors on our freshwater resources, American households flush nearly 25% of their drinking water down the drain. Anybody in the audience venture a guess as to how much of our drinking water we actually use for drinking? 5? Any other guesses? Yes, 1. I heard 1. And that's me rounding up, so we use roughly 1% of our drinking water for drinking. Aside from the 25% that we flush down the toilet, we use 20% on showering, 35% on doing our laundry, dishes, personal hygiene, and other cleaning, 8% towards miscellaneous activities, and we waste the remaining 12% on leaks. So in an era of increasing water stress, you may be wondering, why are we using our drinking water to do literally everything but drinking? And what can we do about this? These are great questions, and this is exactly what drives our work at the center. So if you live in Durham and you're on the city sewer system, your wastewater goes to a wastewater treatment plant, and it gets discharged to a surface water, in this case the Cape Fear or the Neuse River Basin. And if you're out in the countryside, you have some form of a septic system where your wastewater goes into the land surrounding your home. Now, neither one of these systems are generally cyclical, although the latter is becoming more so. And both of them routinely lead to environmental contamination. So what can we do about this? We can get a lot more comfortable with the reuse and our beloved reduce, reuse, recycle mantra. When I ask you the question, what does the future of household water use look like, you might start to picture technologies like the reclaimer. This is the household black water treatment system that's about the size of a refrigerator,
and uses a series of filtration and disinfection processes to take your flush water and turn it into clean water. The first step, the process that I work on, ultrafiltration, removes suspended solids from the waste stream. Activated carbon removes our dissolved organic matter. The third, zeolite, removes ammonia. And the final step, electrochemical disinfection, inactivates our pathogens. The result is a clean water stream that you can use for things like doing laundry, washing your car, irrigating your garden, and you guessed it, flushing your toilet. Technologies like the reclaimer reduce our demand on our freshwater resources, and because we're treating our waste at the source, we reduce the potential for environmental contamination. So the next time you're prompted to think about what the future of household water use looks like in the United States, you might start to think it looks a little bit more like this. And up here we have a picture of Bill Gates drinking reclaimed black water. I'd like to thank everybody for their time, and of course my lab group for asking these questions long before I got there, but inviting me on the journey to answer them. And if anybody has any questions for me, I'll take those now. Yeah, and actually that's why I work on ultrafiltration, because it is the energy hog in the system. So the goal right now, this system was actually developed to be deployed in countries that do not have the sanitation systems that we have in place. So to be run on solar, right now the system currently uses, depending on the demand, anywhere from like a window AC unit to, if you're doing a full household, more of like the cooling for looking at like 10 to 30 like kilowatt hours per day.
How long does the reclaimer take to purify the water?
So that really depends on the scale. If we're looking at like household, I think, I don't want to misquote the number, it's sub 1 hour. I want to say it was like closer to like 10, 20 minutes, but that really depends on if we're doing bigger volumes and more batch process. Thank you. Thank you to August and all of our student speakers. In the interest of time, we're actually going to move ahead into our keynote speaker. So we would now like to welcome our GRADx 2022 keynote speaker, Dr. Nikki Washington. Dr. Washington joined Duke University in 2020 as a professor of computer science, returning back to her native Durham roots. Dr. Washington received her bachelor's degree from Johnson C. Smith University, and then went on to receive both her master's and PhD in computer science. Her career has spanned both industry and academia, including IBM, the Aerospace Corporation, Howard University, Winthrop University, and now Duke, where she has worked tirelessly to increase diversity and participation in computer science. Her prior work has focused on broadening participation in computing, including K-16 curriculum and K-12 computing frameworks, standards, and teacher professional development. Dr. Washington's current research focuses on identity and cultural competence in computing. Our keynote committee was particularly excited by Dr. Washington's research as it has implications and implementations in many fields and is of broad interest to us all at Duke, and we look forward to hearing about her exciting new work. So,
thank you so much. I promise I will be brief because I know I'm standing in between you all and the end of the program, and I know how that is after a long day. So my work, again, focuses on a lot of different things around computer science, but I want to reiterate that this is not just an issue to address in computer science. It is an issue to address in a number of disciplines, especially in STEM. So I'll start with this quote by Bell Hooks, the late great Bell Hooks, who passed away last year. "The classroom remains the most radical space of possibility in the academy." And what that means is that we as educators have the opportunity to really impact and affect change in a number of ways in our field. And so one of the things that I've really tried to focus on is how do I start to create radical spaces in computer science? Because the field itself is known as being very disruptive in terms of the technologies that are created. So you have the social medias and the streaming sites, et cetera. But we don't often think about how to disrupt these disruptive technologies and make sure that we are protecting and eliminating the inequities and harms that are often exacerbated as a result of these technologies. So, first up, what has this space looked like in computer science? If you look at this image here, you see that this is pretty much what we all know of computer science to be: coding, right? Programming, algorithmic thinking, networking, AI, things of that nature. Very theoretical, which is great, and we need that because we need to be able to innovate and develop these technologies. But the problem is that we're not thinking about all of the ways that these technologies tend to exacerbate, like I said before, the harms that are present in society already. So racism, ableism, classism, xenophobia, things like that. But also, who has this space tended to look like? And you can assume pretty much that any white man is what the computer science space tended to look like. Computing was developed by white men in this country for white men in this country. And so if we look back and look at who the three most popular computer scientists you can think of are, these three men will probably come to your minds very quickly: Mark Zuckerberg, Bill Gates, and then Steve Jobs in the middle, right? All great innovators, great thinkers, but all very limited and skewed in how they see things and their positionality in the world. And as a result, the technologies that they've developed have also been very skewed and limited. So, what has this meant? We have a space that has been purely theoretical. We have a space that has been limited to a select group of people based on their identities. And so how has that translated into the technologies that we see? First up, recent news around how Meta and the metaverse was creating harmful spaces for women. Nina Jane Patel detailed her experience within a few minutes of joining the metaverse and how she was immediately sexually assaulted in there. Right? There's now a personal boundaries feature that's put into the metaverse, but that had to happen after a woman was assaulted there. Next up, there's news this week in a New York Times article how AI-driven voice analysis can be used to determine if someone has a mental disorder. Now think of all the ways in which this can create a world of harm for people who have mental challenges or mental health challenges. Also, robot dogs have been used in cities such as New York by NYPD to provide surveillance in communities of color like the Bronx. What does that mean now when we can also equip robots who are already surveilling communities of color to now have the ability to also discharge weapons? And what we've seen over the last 2 years alone in this country, how can that cause even more harm, particularly when we have also issues with things like facial recognition technology that don't properly recognize people with darker skin tones? In the last few months, we've also seen a Harvard freshman who had the bright idea to create FaceTag, borrowing off of Mark Zuckerberg's Face app and the fact that he's also at Harvard, but lacking the understanding of how this could cause a number of privacy concerns when any of us can walk up with our phone and scan a person's face without their permission, and now we have access to their contact information. And then we also have Uber, who for a number of reasons has also been in the news. One was the harm that's being provided when self-driving cars are killing people for these same reasons, that they don't always recognize people based on their racial makeup in terms of skin tone, as well as ability. Because a pedestrian is not always someone who is physically walking. They may be in a wheeled device. And so what does that mean now when a self-driving car does not properly recognize someone? But then also think about it from the case of drivers who were transitioning. And so as they're transitioning and now they have to take pictures in order to make sure that they are still allowed to drive as a Uber driver, what happens when that picture doesn't align with the image that's on their driver's license? And drivers were experiencing being kicked off of the app, trans drivers, because the app was not appropriately accounting for the fact that not every driver is of a binary gender, man or woman, or cisgender even. All right, so that's just the tip of the iceberg with some of the technologies. But then what does that also mean in the environments where these technologies are developed, as well as the academic environments? We've seen over the last few years how Black students and faculty and staff, for example, have detailed, especially in STEM, the ways in which they're experiencing racism and harm on predominantly white campuses. We also have seen the resulting commitment by a number of people in academia especially to start to understand more about the experiences of these students, faculty, and staff in STEM. But then we've also seen companies, for example, like Google, who have been outed for years and then called out even more recently around the harm in which things like badge policing are doing to Black and brown employees there. Badge policing, for example, was a policy where Google employees could walk up to any other person on campus and ask to see their badge to make sure that they were actually where they were supposed to be. Now, we can look at historically the context of that and what that simulates or replicates in terms of people walking and existing in neighborhoods where people don't think they belong, and the power that you've now given to those in dominant identities to effectively determine who belongs in a technical environment. And so even following the murder of George Floyd, we saw that Google and Alphabet CEO Sundar Pichai detailed a lot of the racial commitments that they were going to make. One of those was doing away with this badge policing policy. The issue was it should have never been a policy, but then a couple of months later, we all learned about the firing of Dr. Timnit Gebru, the leading ethical AI researcher there, and all of the ways in which she was calling out harm, both in her research being marginalized and herself as a Black woman being marginalized. And then we also saw, following January 6th, how GitHub, another tech company, was under scrutiny for firing a Jewish employee for noting that Nazis were out protesting at the insurrection, and how in the Slack channels, employees and colleagues were complaining about the fact that he used the word Nazi, even though the people who were out there were also using this language. And he noted that there was even more dangerous rhetoric and harmful rhetoric being discussed on the Slack channels there at GitHub. And then it's not even just in industry. So at the University of Michigan last year, a computer science assistant professor, I emphasize assistant meaning he was not tenured, was resigned after several allegations of women, including graduate students and colleagues, of sexual harassment from him, detailing it with documentation of emails that he had shared, effectively apologizing indirectly for the things that he had done. And then even most recently, we see how a lot of cryptocurrency startups, Coinbase, for example, which was created by one of the co-founders was a Duke student here, how that company itself lost effectively all of the maybe 12 Black employees that they had over a month's time frame, and what that meant in terms of the harms that were being replicated there. And that's just getting to the environment, not even just to the technology that's developed. So my question is, how do we teach to transgress in computer science? Because something is not working, right? We keep seeing that these technologies are still harmful. We see that they are not considerate of the societal disparities and inequities that have been present historically from times of slavery in this country up to present day. So how do we get students, many of whom are dominated by white and Asian, cisgender, heterosexual, able-bodied, middle to upper-class men, to understand the ways in which they have to be responsible for moving outside of just these theoretical concepts into these more social science-related concepts, so that not only they can transgress in their environment and create more inclusive spaces for everyone, but also create better technology that is not just thinking about these things after an event happens. So that's where my work started. The first thing I started to do, create my own radical space as a place of protest, was to create my 240 course here on campus, which is Race, Gender, Class, and Computing. And that class takes students through all of these historical contexts of identity, how it's played out over the years, what are the different forms of oppression and social justice movements that have been dedicated to eradicating that. And then it flips it on its head and says, let's think about it now in the tech space. What does that mean for students or technology users who are now being impacted based on these same identities? But we also have extended that now to training faculty across the country, because that class was great, but Duke is one institution of hundreds in this country, so that means that it's just a small drop in the bucket about affecting a change. So we had to figure out how to get more faculty to impact more students. So that's when we created the 3C Fellows Program, the Cultural Competence and Computing Fellows Program, which works with faculty across the globe. We're really excited that in year 2, we are finishing up our first 2-year cohort, and our second one is in year 1. We have about 200 faculty so far, faculty, staff, and future faculty in terms of graduate students. And then we're all enveloping that under this umbrella of the Alliance for Identity Inclusive Education, Computing Education, And ACE, as we call it, looks to impact the people, policies, and practices that have long impacted students, particularly from systemically marginalized groups. We want to make sure that we are decentering those who are the most minoritized, those who have been the focus for a lot of broadening participation efforts, not just in computing, but in econ, in physics, in biology, et cetera, and saying, let's stop focusing on them and focus on the people who are impacting them, the policies that impact them, the practices that impact them. Because if we keep pouring into those students, we continue to say, okay, you've got it, we gave you mentoring, role models, et cetera. Now go be great and exist in this environment that is still extremely harmful for you. So we're decentering the students and instead focusing on everyone and everything else that impacts them. So our question is, what can this mean in the future? We have yet to know and find out, but we are excited about what we're doing, one, because it hasn't been done, even though it seems so simple, and that's one of the reasons why we still ask this question, and we hope that you will too in your respective fields. So thank you. Am I supposed to open the questions? Okay, sorry, are there any questions? Yes.
So you mentioned implementing this in our respective fields. Have you been able to work with people in other fields besides just computing to implement this?
Yes. So we work heavily with social sciences. So, for example, Dr. Eduardo Bonilla Silva, on campus leading sociologist, works with us on this. We work with Dr. Sophia Noble in gender studies, who's the author of Algorithms of Oppression, other people who are in gender studies, education, for example. So we are targeting computer science because that's the river and lake I'm used to, and I know that area. But we want to make sure we get it right here so that it can serve as a blueprint for a physics, a math, any other space as well. But our key is making sure that we are not the experts. We're leveraging social science and bringing in that expertise as much as possible because the social scientists have been telling us and calling out what these problems are, like Rua Benjamin, Sophia Noble, Tracy McMillan Cottom, others, but we have not listened because we being computer scientists, sit in that very siloed area of it's not theoretical, so it doesn't count. And that's what we're actually trying to push with all of this, so thank you for that. Yeah. So I'll talk about the motivation. The motivation for me was my experiences as a Black woman with a PhD in computer science who often shows up and is one of the few, if not the only. The issues I've had standing before students even and being referred to, for example, as Miss and Mrs., and not being given the appropriate deference of doctor or professor, being called aggressive, rude, and mean and disrespectful because I don't speak in a higher tone voice or because I'm very assertive. And so for me, that's why I say it was this was my form of protest because I knew that I could not depend on, for example, former colleagues, former department chairs, deans, et cetera, to fight those battles for me. The most informative thing and impactful thing I've seen is the ways in which students who maybe hold some dominant identity find ways in which they haven't understood other things. And it's starting to open their eyes up to experiences that they never knew or they couldn't fathom. I had a young woman a couple of semesters ago, young white woman from a very affluent background who said that I only ever knew what it was like to be me. And so I never thought about how other people are experiencing the same things that I experienced, even as a Duke student. I've had students who are also from minoritized groups who, because there's a lot of journaling and reflection, it's not a typical computer science course, who share these kinds of things in their topics as well. Students who have family members who may be undocumented, students who may be scared to come out yet, but they're talking and thinking through the ways in which this class is giving them the confidence to have these conversations outside of just the classroom and in their other courses and also in their lives with their families and beyond. Thank you.
So, on behalf of the entire GRADx Coordinating Committee, we would like to thank all of today's student speakers and our keynote speaker, Dr. Washington. Sorry about that. One more round of applause for Dr. Washington. And we would like to thank all of you here in person and on Zoom for attending today and for all of your great questions. We invite you to join us right in the lobby for a reception and continued discussion with today's speakers. And if all the speakers could also hang back for a second, we also have gifts for you. So thank you once again.